Myself, Birappa Sodati. My seminar topic is ionization of weak acids and weak bases. Ionization of weak acids and weak bases. The definition of the ionization, the process in which neutral molecules gets splits up into charged ions when exposed in the solution, is referred to as the ionization of a compound. Ionization of a compound. While the bases are those compounds that furnish the hydroxyl ions in the aqueous medium, the degree of the ionization of the acids and bases helps determine its strength. Ionization of acids. The degree of ionization refers to the strength of an acid or a base. The strong acid is said to be completely ionized in the water, and weak acid is said to be partially ionized in the water. There are different degrees of ionization of acids or different levels. Strong acids. Strong acids are the completely dissociated in the water. Strong acids, the larger will be the acid ionization constant. This means the this means that a strong acid is better proton donor. For example, strong acid HCl, it splits up into the H plus and Cl minus. Weak acids are the partially dissociated in the water. The weaker acid, the smaller will be the acid ionization constant. Since ionization of weak acid is an equilibrium, the chemical equation of the weak acid is expressed in the Ha plus in aqueous medium plus H2O in liquid, equilibrium sign S3 S3O plus A minus. The dissociation constant of acid is K is given by concentration of S3O plus and concentration of A minus divided by concentration of Ha and concentration of water. Its concentration of water is given is equal to the 1. For example, weak acid, acetic acid, is splits up into acetate ion and H plus ion. Ionization of bases. Some bases like sodium hydroxide or lithium hydroxide gets completely dissociated into their ions in an aqueous medium, which referred to as a strong base. NaOH splits up into Na plus and OH minus. Weak base. Some bases like ammonium hydroxide are partially dissociated into their in an aqueous medium, which is referred to as a weak base. NH4OH splits up into ammonium ion and hydroxide amine. Dissociation constant of base is given by denoted by Kb is equal to the concentration of OH minus into concentration of Ha plus divided by concentration of A and concentration of water, where concentration of water is equal to the 1, where Kb is the equilibrium constant for the ionization of base. Therefore, we can say that a strong base implies a good proton donor, while a strong acid implies a good proton acceptor. Dissociation of weak acids in water. Acetic acid plus water gives rise to acetate ion and protonium ion. Dissociation of weak base in water. Ammonium plus water. Ammonium ion plus hydroxide amine. Dissociation constant for acid is given by acetate ion into H plus ion divided by concentration of acetic acid. For dissociation constant of bases is given by Kb equal to NH4 plus OH minus divided by ammonium hydroxide. Expression for degree of hydrolysis. Let us consider hydrolysis of salts of weak acid and weak base. Ammonium acetate plus water gives acetic acid and ammonium hydroxide. At the time t equal to 0, the concentration is of the reactant is C and product is 0. At the time t, the concentration is of the reactant is C1 minus alpha, product is C alpha. Hydrolysis of the constant dissociation is given by alpha C into alpha C divided by alpha 1 minus alpha into C 1 minus alpha. Dissociation constant of hydrolysis is alpha square C square divided by C square 1 minus alpha square, where 1 minus alpha is equal to the 1. Hydrolysis of dissociation constant is given by alpha square. Alpha is equal to square root of kh, where kh is equal to kw divided by ka into kb. Alpha is equal to square root of kw divided by ka into kb. Mathematical expression for hydrolysis constant, degree of dissociation, salt of weak acid and weak base. Consider the equation ammonium acetate plus water is gives to acetic acid and ammonium hydroxide. Apply the law of equilibrium. Dissociation constant of hydrolysis acetic acid into ammonium hydroxide divided by ammonium acetate ion. KH is equal to acetic acid ammonium hydroxide divided by ammonium acetate. We know that acetic acid is splits into acetate ion and H plus ion. Dissociation constant for weak acid Ka is given by acetate ion, concentration of acetate ion and concentration of H plus divided by concentration of acetic acid. Ammonium hydroxide is splits into ammonium ion and hydroxide. Is the addition constant for weak base is given by Kb NH4 plus OH minus divided by NH4 OH. Water splits into H plus and OH minus. Dissociation constant for water Kw is equal to H plus OH minus divided by concentration of water. Kw is given by concentration of H plus and concentration of OH minus. Multiplying the equation 1 and 2 and 3, we get that Kw is equal to H plus ion and OH minus. Kw is equal to the concentration of H plus and concentration of OH minus. Kw is equal to Kh into Ka into Kv. The expression for the mathematical expression for hydrolysis constant degree of dissociation of salt of weak acid and weak bases.